All right, ladies and gentlemen, let's try another problem for a projectile that is launched straight up. You should have a paper that looks like this one. The boy throws a ball straight up at a velocity of 60 meters per second. How high is it 3 seconds later? Okay, let's look at this problem and acknowledge something right off the bat. By now, I hope you've gotten pretty good at pulling the information out of this. The initial velocity is 60 meters per second, so Vyi is 60 meters per second. That's the starting position for our problem, so we're going to call that Yi equals 0. Starting position is 0. We know that 3 seconds passes, and we're looking for where the ball is located 3 seconds later. So we're looking for that final position 3 seconds later. Now, one of the things about this problem that's different than the one we did before is that we don't know if it's at the peak 3 seconds later. It would take a quick calculation to determine that, and I can tell you that it will not reach its peak in 3 seconds. But we have to, the reason I point that out is to be careful not to assume when you have a projectile problem that that you're dealing with it going all the way to the peak or all the way down from the peak. We can find out information about what's happening on the journey to the peak or the journey back down. So this is one of those problems where we're going to find out how high the ball is 3 seconds after it's launched, which will be before it's reached its peak. All right, so on the paper you should have made these notations on the picture and filled in this information down the side, indicating the variables that we know. Again, I want to reiterate that it's absolutely imperative that whenever you fill out this given list that you indicate this variable exactly this way, that we're talking about Vyi equals 60 meters per second. You can't leave any of that out. All of that is important, and that's the quickest and the most accurate way you can say this. You can't just say velocity equals. You can't just write 60 meters per second. You must include that whole equation. So that's true for each of these entries in green. So be sure you're doing that on each one. Okay, what we're looking for is the position in the vertical direction at 3 seconds. So we're looking for a final position at 3 seconds. We have to determine which of our equations is going to help us. So let's go through that process and see if we can determine which equation will help us. If we're looking for a final position, this equation does not give us a final position, nor does this equation give us a final position. It will give us a change in position, so that could be helpful, but we don't know a final velocity. We know a starting velocity, but we don't know how fast it's going after 3 seconds. So we're going to go to our trusty equation here at the beginning, YF equals YI plus VYI times T plus 1/2 GT squared. We're going to use that one. So if we start substituting, YF is what we're solving for, so we leave that in as a variable. We drop 0 in for YI, then we drop in 60 meters per second for VYI, and for T we drop in 3 seconds. Then we add to that 1/2 times the acceleration of gravity, which is negative 10 meters per second squared, times 3 seconds, all squared. As we make our way through this problem, this drops out because adding 0 to something doesn't change it. So if I take 60 meters per second times 3 seconds, the seconds cancel, and I get 180 meters. Then I'm going to add to that this partway through its simplification. I can take 1/2 times negative 10 meters per second squared and get negative 5 meters per second squared. And then I can square 3 seconds and get 9 seconds squared. Then if we come down for the next line, the 180 just comes right down. Then we're going to multiply these two, negative 5 meters per second squared times 9 seconds squared, gives us a negative 45 meters. Adding those values together, we find that the final position is a positive 135 meters. So our final statements for this problem is the ball is 135 meters in the air 3 seconds after it is thrown upward. So I hope you did well with that one. You have a few more to practice on your own now. Good luck.